Day 2. This lesson is on multiplying matrices. And we learned that in order to multiply a matrix at all, you have to look at the dimensions, okay? This is a 2 by 2 matrix, all right? 2 rows, 2 columns. This is also a 2 by 2 matrix, all right? But to be able to multiply two matrices together, they do not have to be the exact same dimensions. What matters is the inner dimensions. They have to match, this 2 and this 2. So this is a possible matrix to do. And also we know that the resulting matrix is going to be a 2 by 2 matrix, and I'm basing that on the outer dimensions. Right? The outer dimensions tell me that the result is going to be a 2 by 2 matrix. Okay, so that means when I organize my thoughts, I'm picturing a 2 by 2 matrix like this. Okay, and this is going to be element 1, 1, because this is first row, first column. This is element 1, 2, first row, second column. This is element 2, 1, second row, first column, and this is element 2, 2, second row, second column. Alright, so the way I go about finding each of these answers, and I guess I will just record them over here as I go, is I'm just going to do this one by one. So say if I want to find element 1, 1, I know that that is going to be row 1 times column 1. All right, that's row 1 of the first matrix times column 1 of the second matrix. So in other words, I've got 2, negative 3 times 3, negative 2. If I put that together, that's going to, I'm multiplying here, that's going to give me 6, and that's going to be also 6, so that's going to make 12. Alright, so that means I'm going to have a 12 here. Okay, now if I want to find, say if I want to just go down and find element 2, 1. Alright, so that's going to be row 2, column 1. So instead of row 1, now I'm doing row 2 times column 1. So that's going to be 4, 1 times 3, negative 2. And that is going to give me 12, I'm multiplying, and negative 2, which is 10. Okay, so that gives me this element, which is 10. Okay, now I'm going to go ahead and find, for example, element 1, 2. Okay, so element 1, 2. Okay, I'm finding this element right here. That's going to be row 1, column 2. Okay, so let me start that over. So now I'm talking about row 1, okay, column 2. Fine, so row 1 is this 2, negative 3, and column 2 is the negative 2, 0. Okay, I'm multiplying, so that's going to give me negative 4 and 0. If I add those up, I get negative 4. Okay, I really could have put a box around these little answers. So, negative 4 is going to be my this element right here. And last but not least, element 2, 2. Okay, that's row 2, column 2. Okay, so I'm doing right here, row 2, column 2. So that's going to be 4, 1 times the negative 2, 0. So that's going to be negative 8 and 0 as we multiply. So that gives us -8 for the last element. Okay, so there it is. This is the product for problem number 1. And that basically shows how you do it. Alright, so I'm going to switch colors. I'm going to do this next one in red because this can get pretty tight. Now looking at the dimensions of number 2. This is a 2 by 3 matrix. Okay, so this is 2 by 3. And this one is a 3 by 2 matrix. Okay, so this one is 3 by 2. The inner dimensions, those 3's, match. So that means this is doable. Now the outer dimensions tell me the dimensions of the answer, the product. So that's why I know the product, the answer, is going to have dimensions 2 by 2 again because of the outer dimensions. Okay, so once again I'm looking at this kind of a model. Let me leave myself more space. So if I know it's going to be a 2 by 2 matrix, then I'm talking about like this. Alright, element 1, 1, element 1, 2, element 2, 1, and element 2, 2. Exactly the same as last time. Okay, which was also a 2 by 2 matrix. So let's just find these one at a time. Okay, I'm going to try to zoom in a little bit more. Okay, so as I find element 1, 1, okay, this is going to be row 1 times column 1. So I'm talking about, maybe I'll do the highlighter. So I'm talking about row 1 times column 1. Okay, row 1 times column 1. So if I do that, I'm going to have this. Row 1 is 2, 1, -5. Okay, column 1 is 1, -4, 4. If I multiply, I get 2, -4, and -20. If I add all those up, okay, -20 and -4, that's -24, plus 2, that's -22. Okay, so that tells me the value of element 1, 1. You know what, maybe I'll squeeze this in right here. The answer. Okay, so that tells me I have a -22 right here, element 1, 1. So I'll keep going. Now I'm going to do element 2, 1. Okay, that's row 2, column 1. So here I go, row 2. Alright, the highlighter thing wasn't really working for me that well. Yeah, you're fine. So we're talking about row 2, column 1. So this is row 2, and this is column 1. Okay, so row 2, so that's going to be 3, 6, -1. And then column 1, so that's 1, -4, and 4. If I multiply those, I'm going to get 3, -24, and -4. Alright, so if I add these, okay, that's going to give me, so I've got -21, and then -4, so that's -25. Okay, so that should be element 2, 1. Okay, right here. So this is my -25. Alright? Now I'm going to go ahead and find element 1, 2. Okay. Maybe I can squeeze this in over here. So element 1, 2. So that's going to be row 1, column 2. Okay, so we're talking about row 1, column 2. Okay, so looking at that, so row 1 is like this. It's 2, 1, negative 5. Column 2 is negative 5, negative 6, and negative 2. If I multiply all that together, I get negative 10, negative 6, and positive 10. Well, the positive 10 and negative 10 cancel each other out, so that's just going to leave negative 6. Okay, so element 1, 2, which is right there, that's negative 6. Now, one more. We still need element 2, 2. Okay, so let's do this right here again. Element 2, 2. So that's row 2 and column 2. Okay, so this is row 2 and this is column 2. So if I set those up sort of next to each other, so that's going to be 3, 6, negative 1. Okay, that's row 2. And then column 2 is our negative 5, negative 6, and negative 2. Multiply, multiply, multiply. I get negative 15, negative 36, and positive 2. Okay, negative 15, negative 36, positive 2. Alright, just double checking. Okay, so I'm getting negative 49 out of this. And that is the final element. Okay, so that should be the answer for problem number 2. Okay, let's look at number 3 and see if this is even doable. Okay, first let's look at the number of rows and columns. So let's see, the dimensions for this first matrix are this is a 3 by 1. Okay, 3 rows, 1 column. Looking at the next matrix, this is a 1 by 3. Because it's got 1 row and 3 columns. Okay, I know this is going to be doable, alright, because the inner dimensions are the same. And I know that the final answer is going to have the shape 3 by 3 because of the outer dimensions. Okay, so the final answer will be a 3 by 3 matrix. So that means the final answer is going to take this form. I'm just going to set it up and we're going to fill these in one at a time. So it's got to be 3 by 3, so it's going to be sort of like this. Okay, and this is element 1, 1 because this is row 1, column 1. And this is element 1, 2. Row 1, column 2. This is row 1, column 3. And this is row 2, column 1. Row 2, column 2. Row 2, column 3. This is row 3. Everything down here is row 3. So row 3, column 1. Row 3, column 2. Row 3, column 3. So these are all the elements that we have to find one at a time. Okay? So let's just go in order. So element 1, 1. Okay, that's row 1, column 1. All right, well, look, row 1, this is row 1, and this is column 1. Okay, so that's just 3 times -1. Okay, so that's just -3. All right, and normally we would add if there were more numbers, but that's it. So it's just -3. Okay, so I can put a little box around that or something. But you know, I think I'm going to fill these in as I go this time. So element 1, 1. Maybe I won't. All right, I'll just keep going and I'll fill in the final answer later. But that is this. Okay, so let's keep going. Let's go element 2, 1. All right, that's row 2, column 1. So here is row 2, and this is still column 1. So that's just 0 times -1, which is 0. Okay, I'm just going down like this. So next I have element 3, 1. Okay, so that's row 3, column 1. All right, so row 3, column 1. So that's 1 times -1. Okay, so these would be the first 3 numbers right there. Okay, just gotta make sure I have enough space. I'm just gonna wrap around and keep going. So next I'm gonna do these 3. So I'm gonna do element 1, 2 now. So element 1, 2. Okay, that's row 1, column 2. All right, this is row 1, and this is column 2. So that's just 3 times -2. That's -6. All right, now let's do element 2, 2. So that's row 2, column 2. So this is row 2, this is column 2. So that's 0 times -2, which is 0. Okay, now let's do this one, element 3, 2. Okay, that's row 3, column 2. So here's row 3, and this is still column 2. So that's 1 times -2, which is -2. Okay, so we just have one more column left. All right, now we're going to do this final column. So I'm doing E1, 3 now. So that's row 1, column 3. So this is row 1, and this is column 3. Okay, so that is 30. All right, next, element 2, 3. That's row 2, column 3. Row 2, column 3. So that's 0 times 10. Which is 0. And finally, we have element 3, 3. Row 3, column 3. Alright, so here is row 3, and here is column 3. So that is 1 times 10, which is 10. Okay? So if I put all these together, I should be able to form my answer. And I'll squeeze it in right here. Okay, so my answer is -3, 0, -1. Okay, that was these guys. Okay, we kind of split it up like this. And then we had the second column was -6, 0, -2. And then the third was 30, 0, and 10. Okay, so this would be the final answer, that 3 by 3 matrix we were looking for. Alrighty then. So that is how you do number 3. What is next for us? Let's look at number 4. Alright, let's talk dimensions for number 4. This first matrix is a 1 by 3 matrix. Okay, that is a 1 by 3. Okay, because it is a 1 row and 3 columns. The second matrix is a 3 by 1 matrix. It has 3 rows, 1 column. So it is a 3 by 1 matrix. So, first of all, this is possible because those inner dimensions are the same, 3 and 3. Now, I will know the dimensions of the product, the final answer, by looking at the outer dimensions. Okay, so the final answer is going to have the shape 1 by 1. So that is going to be a tiny 1 element matrix. Okay, so our final answer is just going to have this form. It's only going to have 1 element in it. Alright, and it's going to be row 1, column 1, that's it. So basically, to find the answer to this guy, okay, I just need to find this one thing. And this 1, 1 means row 1 times column 1. Well, guess what? This is row 1, and this is column 1. So if I do go ahead and put those together, row 1 is 6, 1, -4. Column 1 is 2, 2, -2. That's going to give me 12, 2, and 8. 8 plus 2 is 10, plus 12 is 22. That's it. That is the 1 element answer. Okay, so let's put some brackets around it and call yourself done. Okay, so this is the product. It is a 1 by 1 matrix that just has the number 22 in it. Okay, let's take a look at number 5. Let's see what's going on. Okay, looking at the dimensions here, this is a 3 by 3 matrix, 3 rows, 3 columns. So I know this is a 3 by 3. This matrix is a 2 by 2 matrix, all right? It has 2 rows and 2 columns. Looking at the inner dimensions, the 3 and the 2, I see that they do not match. So right away I know that this one is going to be not possible or undefined. Okay. All right, that's quick and easy, so we can just move on. All right, will we get that lucky again for number 6? Let's see. The dimensions here are 3 by 2. So this is a 3 by 2 matrix. The dimensions here, this is a 2 by 1. 2 rows, 1 column. Looking at the inner dimensions, I see they're both 2. They do match. So it is going to be possible, so I have to go ahead and do it. To know the shape of the answer, I will look at the outer dimensions. Alright, the outer dimensions tell me that I'm going to have a 3 by 1 matrix answer. Okay, in other words, it's going to have 3 rows and 1 column, so it's going to have this shape. Alright, E11, E21, E31. Okay, the answer is going to be a 3-row, 1-column matrix, and these will be the elements. Okay, because this is row 1, row 2, row 3, and all of these, you see all these ones, because this whole thing is column 1. Alright, so we just need to do these 3 calculations to find out what these elements are. That bell you just heard is my lunch, so I need to pause this and go serve my lunch duty. Eat my lunch on the run. I think I'm in the pavilion today. Anyway, maybe I'll see you outside. I will finish this afterwards. Back from lunch. Where was I? Okay, so I was about to do element 1-1. So element 1-1, that's row 1, column 1. So this is row 1, and this, of course, is column 1. So that would look like this. -1, 5, and then 3, 1. So that is -3 and 5, which together makes 2. Okay, so that's that. You know, this one I guess I can go ahead and build it as I go. Alright, so I've got 2 so far. Now I'm going to do element 2-1. Okay, so element 2-1, that's row 2, column 1. Did I miss? Okay, so this is row 2, column 1. So that's 2, -3, that's row 2. And then column 1 is 3, 1. Okay, so that's going to be 6 and -3, which is 3. That means I'll have a 3 here. Last one more. Let me make sure I'm not taking up the space for number 7. Nope, still got lots of room. Alright, last one is element 3, 1. Okay, element 3, 1, that's row 3, column 1. Why are you working so slow right now? Okay, so this is row 3, column 1. So that's why we're going to have 4, -2, because that's row 3, and then 3, 1, that's column 1. So that's 12, and -2, so that's going to be 10. So that means this is going to be 10 right there. Alright, so that is the answer to number 6. Alright, and that's the bell for me to start getting ready for class. So I suppose I will have to finish this after school.
Yeah. Mr. Byrne, there's a problem.
Alright, so looking at number 7, I need to multiply by this scalar, multiply everything by -2. Okay, so if I multiply all of these by -2, that's going to make -4, -8, -6, +2, -2, -10, -2, 4, 6. Okay, so that's this matrix. And in this one, I'm just going to recopy it as is. So these are the two matrices I'm now going to be multiplying. This is a 3 by 3 matrix, and this is also a 3 by 3 matrix. Because the inner dimensions are the same, I know that it's possible. Because of the outer dimensions, this is what tells me the shape of the answer, the dimensions of the product will be a 3 by 3 matrix. So I know for my final answer, I am looking for 3 by 3. Okay, so for example, a 3 by 3 matrix is like this. Okay, 3 rows and 3 columns. So, for example, I know this is element 1, 1, 1, 2, and 1, 3. This is 2, 1, 2, 2, and 2, 3. This is element 3, 1, 3, 2, and 3, 3. So I need to find all 9 of these elements one at a time. So let's go. For example, if I wanted to find, and maybe I think I'm going to just erase these one by one and put them in. So say if I want to find element 1, 1. I know that is going to be row 1 times column 1. So this is row 1. And this is column 1. Okay, so row 1, so that's -4, -8, -6. Alright, and then column 1 is 0, -2, 10. If I put all that together, by multiplying, I'm going to get 0, 16, and -60. Okay, if I put those together, alright, so this comes out to be -44. And at this time I think I'm going to fill these in one by one as I go. So this was -44. Okay, and I'm just going to do the same thing like 9 more times. Let's see, can I do this any faster? Because this is getting tedious. Okay, I'm just going to keep going straight down. So if now I want to do element 2, 1. So that's row 2, column 1. So row 2, that's 2, -2, 10. Column 1 is still this, 0, -2, 10. Multiplying, that's going to give me 0, 4, and 100. Man, these numbers are getting big all of a sudden. Makes me feel like I'm making a mistake. Oh wait, that's a negative. 2, -2, -10. Phew, that's close. Still a big number, so -100. Put these together, that's going to give me -96. Okay, so that's E21, so that's this right here. Okay, let's go for another one. Why not? This is crazy. Alright, so I'm doing 3, 1, element 3, 1. Okay, so I'll do that up here. Element 3, 1. That is the row 3, column 1. Okay, so here's row 3 is negative 2, 4, 6. And then column 1 is 0, negative 2, 10. So that is going to give me 0, negative 8, and 60. So that is going to give me 52. Okay, so 52 is my next element, element 3, 1. So I'll put that right here, 52. All right, I'm going to do the next one now, element 1, 2. Element 1, 2, that's row 1, column 2. So this would be row 1, and this would be column 2. Okay, so it would be like this. Negative 4, negative 8, negative 6, 1, negative 1, 4. So that is going to be negative 4, positive 8, negative 24. Add them up, and I'm going to get negative 20. All right, so negative 20 is going to go right here. Well, where these crazy numbers come from? It's a mystery. All right, so I'm going to get negative 20. And look, I'm just going to do that same process over and over again and getting the rest of these. But I'm hoping that you get the idea based on what I've done so far. And so I'm just going to go ahead and fill in the rest of these with some answers, ladies and gentlemen. So, for example, this one should turn out to be negative 36. All right, this one will be 18. This should be negative 10, negative 16, and negative 2. All right, so that was number 7. Let's see what's on the back. Okay, we've got a few problems on the back. C squared, all right, that means multiplying matrix C by itself. So we need to take this matrix, which is 3, negative 1, 0, and 5, and multiply it by itself. Okay, 3, negative 1, 0, and 5. Okay, we know that this is a 2 by 2 matrix, and this is a 2 by 2 matrix. Because of the inner dimensions, I know this is doable. Because of the outer dimensions, I know that this is going to be a 2 by 2 answer. So basically my answer matrix is going to be in this form. Okay, and I know that this will be element 1, 1, and this will be element 1, 2, element 2, 1, element 2, 2. So let's just find these one at a time. Okay, so let me start with element 1, 1. Element 1, 1, that's row 1, column 1. Row 1 is 3, negative 1. That's row 1. Column 1 is 3, 0. All right, 3 times 3 is 9. That's 0, so that's 9. Okay, so that tells me that this is 9. Okay, now let's do element 2, 1. Okay, element 2, 1, that's row 2, column 1. Row 2 is 0, 5. Column 1 is 3, 0. So that's going to be 0 and 0, which makes 0. Okay, so that tells me that this is going to be 0. Alright, now let's go ahead and find element 1, 2. Alright, that's row 1, column 2. So row 1 is 3, negative 1. Column 2 is negative 1, 5. So that's going to be negative 3 and negative 5 when we multiply, and that is going to be negative 8. Alright, last one. Okay, let's do element 2, 2. Alright, that's row 2, column 2. Row 2 is 0, 5. Column 2 is negative 1, 5. So multiplying gives me 0 and 25, so that is 25. So this last element here is 25. Alright, so that is the answer to number 10. Okay, how about number 13? Okay, we only have 2 problems left. So number 13. First we have to do 3 times C. Okay, this is going to be a multi-step process. Alright, so I'm supposed to do 3 times matrix C. Alright, so I'm doing 3 times, let's see what we got here. 3, negative 1, 0, and 5. Okay, so that's 3C minus 2 times A times B. Alright, so here's a little picture of what's happening. We're doing 3 times C minus 2 times A times B. Okay, so I need to just do this in stages. So for example, I could go ahead and multiply. I could go ahead and multiply 3 times all of these. I feel like I'll change colors now. So if I do that part of it, that's going to give me, okay, that's going to give me 9 and negative 3 and 0 and 15. So there I've multiplied everything by 3. Now over here, I think I will save the 2 for the end, for the next step, and I think I'll go ahead and multiply these 2 together next. So let's do our little dimensional analysis. Okay, this is I'll do it up here. This is a 2 by 3 matrix, 2 by 3. And then this one is a 3 by 2 matrix, which means that the answer is going to be a 2 by 2 matrix. Okay, because of the ends will be a 2 by 2 matrix. So that's helpful to know, because as I set this up, I will put this in the shape of a 2 by 2 matrix. Okay, with the little spots here. In fact, let me just go ahead and really get it ready. There's 2 by 2. So off in the margins somewhere in the empty spaces, I will do all these little elements. Okay, like for example, okay, this right here, that would be element 1, 1. Okay, I'm talking about row 1, column 1. So that's going to be 205, because that's row 1, times column 1, which is 6, 10, negative 2. Okay, that's going to make 12, 0, and negative 10. Okay, that's going to make 2 when I put these together. 2. Okay, so that tells me that this right here is 2, for example. Alright, now I would just need to do that 3 more times. Okay, so for example, I'll just go downward. So if I do element, this would be element 2, 1, because I'm talking about row 2, column 1. Now here's row 2 right there. That's my -1, 3, 2. Okay, that's row 2. And here's column 1. 6, 10, -2. So that's going to give me -6, 30, -4. Whoops, why did I put 40? Thinking ahead. Okay, so that's going to be 20. Okay, so I just did element 2, 1, so this is going to be 20. All right, and okay, so I need to do this next one. All right, let's see, can I squeeze this in down here? So now I will do element 1, 2, row 1, column 2. So row 1 is my 205. Column 2 is -3, 0, and 1. That's -6, 0, and 5, which is -1. Okay, last but not least, I will do element 2, 2. Okay, that's row 2, column 2. Row 2 is -1, 3, 2. Column 2 is 6. No, that's column 1. Column 2 is this, -3, 0, 1. Put it all together, that gives me 33. No, that's not 11. That is a 1. My mind's playing tricks on me. I'm so tired. -1 times 3 is +3, 0, and 2. So that's going to be 5. Okay, so I'm going to have that as my little matrix. I really hope I did not make a careless mistake, because I don't have time to fix it right now. So fine, I multiplied those two together and I got this. Now I'm going to do my little scalar multiple thing. Alright, I'm going to multiply everything by 2. Okay, so if I multiply everything by 2, then I'm going to have 4 and -2 and 40 and 10. Okay, so now this is what I have. So I have this matrix minus this matrix. So when it comes to subtracting, I just do, I subtract the corresponding elements. So 9 minus 4, that's 5. -3 minus -2. That's the same thing as -3 plus 2, all right? Minus a negative is addition, so that's going to be -1. 0 minus 40 is -40. And 15 minus 10 is 5. Okay, so I'm pretty sure that this is going to be my final answer, unless I made a careless mistake someplace, which is entirely possible. Alright, considering I looked at this and thought this was an 11. Alright, anyway, one more problem. This video is getting too long. I think I need to zoom out. Okay, Fred earns money by doing yard work for Mr. Capri. The number of times that Fred mowed and weeded Mr. Capri's lawn is given by matrix A. Okay, so I guess in May he mowed the lawn 3 times and weeded twice. In June he mowed 4 times and weeded 3 times. Alright, fine. The amount that Fred earns for each task is given in matrix B. Alright, so I guess he earns $10 for every mow and $8 for every weed. Use matrix multiplication to determine the total amount of money that Fred earned in May and June. Okay, so basically we're just going to do matrix A times matrix B to get this done. So if I do that, okay, matrix A here is this lovely 2 by 2 matrix. Matrix B is a 2 by 1 matrix. Okay, that means the answer is going to be a 2 by 1 matrix. It's the end dimensions. So the final answer is going to be 2 by 1. Okay, like this. It's going to be 2 numbers. It's 2 by 1. So it's kind of like this. Entry 1, 1. Alright, entry 2, 1. So let's do these calculations off to the side. Okay, and this is going to give me the amount, alright, in May and June. Okay, is going to come from this. And from the second matrix, we're going to get this column. We're going to get how much earned. Okay, that's how it goes. When you multiply matrices in a real world problem, okay, the rows come from the first matrix, you know, in terms of what they are, May, June. The columns come from the second matrix. In this case, how much is earned. So let's go around and find each of these things. So let's do element 1, 1. That's row 1 times column 1. So that's going to be row 1, so 3, 2, times column 1, which is 10, 8. So that's 30 and 16, so that is 46. Okay? So that is 46, and we're talking about how much earned, so that's $46. And then now we're going to do element 2, 1, row 2, column 1. Row 2 is 4, 3. Whoa, it's not a fraction, Burton. Like I say, row 2 is 4, 3. Column 1 is the same thing, it's 10, 8. If I multiply that together, that's going to be 40 and 24. So that is 64. Alright, and again, this is how much he's earned, so that's $64. Alright, so that means in May he earned a total of $46. In June he earned a total of $64. So if I want to know, you know, so that's the total that he earned in May and in June. The way I read the question, then that's what I think that they were trying to find out. Now, if they really mean the total, okay, another way to read the question is that what's the total amount he earned for both months? Obviously, I would just add those up, and the overall total would be $110. Okay, in case that's how you read the question, then that would be the answer. Alright, let's finally put an end to this video and call it a night.